TypeScript team is porting TypeScript to Go. And that is going to be something that will improve performance by like tenfold, if not more. Once it does ship, it'll be like one of the coolest releases in a long time.
Hi, and welcome to PodRocket, a web development podcast brought to you by LogRocket. I'm Josh, and today we have Mike Hartington, Director of Developer Relations at NX, here to talk about TypeScript performance. In this episode, Mike and I talk about TypeScript performance, of course, project references compared to native workspaces, and very exciting, TypeScript's in-progress port to Go. So here's our episode with Mike Hartington. Hi, and welcome to PodRocket, a web development podcast brought to you by LogRocket. So first of all, Mike, hi, welcome to the podcast.
Hello, thank you for having me. Excited to be here.
You're a great person to talk to. React Miami is a great conference. TypeScript performance is such a fascinating deep dive. So just to start off, TypeScript has performance things you are talking about. Why do you keep using TypeScript despite the fact that you're also kvetching about its performance?
I remember the life before TypeScript and the tooling before TypeScript, and I don't really want to ever go back to that. For the newer developers in the crowd, there was nothing that provided really accurate and good type analysis in your JavaScript program. So like, despite TypeScript having some performance issues, it is still a far better tool than what we, came from in the past. So it's like, just, is that good that despite its issues, I will continue to use it?
I also want to push back on the performance issues a bit. If you're starting a new project, you have maybe a dozen files. Will you notice anything wrong with TypeScript?
Absolutely not. I did want to make sure that it came across when I was kind of going through it. Most people never run into the issues that I was kind of highlighting for the most part. It's only like once you hit 100, 200 files, large monorepos, or if you're on like a CI environment where the resources are super restrictive and you're not running stuff with enough memory, and you'll run into bottlenecks there. But you still have to hit that other hurdle of the code base is pretty large. And that scale is really like what drives a lot of the performance issues. But your greenfield projects or your hello worlds, you will never notice an issue.
Let's dive in then. What makes a type slow, or how do you define slowness when it comes to TypeScript?
I kind of focused it on two parts. One is like throughput. So like TypeScript itself and the compiler itself, TSC, basically has to go through and analyze all your files, figure out the types, whether it's kind of evaluating that by just following the symbols, or it has to go through and check the type that you have annotated onto your variables. Where that kind of performance issue kind of sneaks in is if you have so many files and they're all in the same kind of workspace, there's a lot of back and forth and kind of traversing of your program for TypeScript to like fully understand, hey, this, you passed in a string, it expected a number. That whole step of, I have to now know everything about this program to be able to tell you that you have an issue in this file, tends to be like the major performance impact. And we see this a lot with like some of our customers at NX that they are in, the enterprise. The expectations for large code bases are completely different, and they're okay living with, 2-3 minutes for TypeScript to compile, but it could be better.
Just to clarify for folks who haven't used TypeScript much, does this impact runtime code in any way?
No. This is a build time only issue. I think with the runtime code tends to be pretty much like no performance impact other than like how are you bundling. But the build step itself and being able to like compare the compiler speed is really just like it's a dev ergonomics or a dev experience versus actual user experience.
That's such a great delineation. And the two really feed into each other, right? If you have a great dev ergonomics or dev experience repo, then you can write better code. What is the impact of having something like, say, a very slow TypeScript type check or some other tooling issue on dev ergonomics, and how does that feed into the user experience?
I mean, who wants to work in a repo or a project where everything just feels painfully slow? Like some of the demos I've been working with, like the compile time is over 2 minutes, 3 minutes. And if I'm having to go in day out, work on a project that takes 3 minutes, just not even to fully compile and build runtime code, but just to do type checking, that to me, I'm not going to want to put my best effort in on that project. I'm just going to want to be like, well, forget this. I'm already frustrated because everything's so slow. I'm not going to care about the actual product that I'm trying to work on.
Let's dig in a little bit deeper even into what causes these slow types. You mentioned that there are issues when you have throughput of TypeScript across different packages. What have people traditionally done between or to link these packages that isn't playing so well with TypeScript performance?
So in larger projects, I think the biggest thing that tends to be the cause of these issues is something called TypeScript paths. And if you've ever looked at a project where like you have your TS config, there's a paths setting inside of your compiler options. That tends to be like the only cause of it, but that tends to be like the big cause of like slowness. Because the promise of paths is that people have used them as like, I'm isolating this chunk of code to its own folder, and I'm just going to import from that code, and it's isolated, and it's in its own directory, and therefore it's never going to impact overall performance. But paths don't really work that way. They make sense in like maybe smaller projects where all you have is like, I'm just rewriting a couple different import statements, but paths really are just like a shorthand, so that way when the compiler sees, oh, import something from @utils/ whatever file name or whatever entry point, it's just going to take that mapping for that alias and put in the relative path information that you set in your TS config. So like the isolation that you think you're getting doesn't actually exist. And that right there kind of tricks people. They think it's isolated, it's not isolated. So the compiler still is treating everything as just like one giant program.
Whenever someone says one giant in the context of performance, that seems like it's a good code smell for what might be causing issues.
The easy way to kind of fix that is to use like two key things that are relatively new in the grand scheme of everything: project references and workspaces, which are two different things for different purposes, but end up being beneficial to your overall experience.
Let's talk about those two. TypeScript project references. What is this?
Yes. Basically, this is like a built-in way for TypeScript to treat units of code as isolated modules. So I think in most people's projects, they're used to seeing one TS config, probably at the root. With project references, you can start to split up your code base into smaller TypeScript modules, where each directory, for instance, could have its own TS config. And it's got all the compiler settings. It might be extending from like a base settings, but it's essentially just a way for TypeScript to see, I have this directory, it's got a TS config, I'm going to compile it in isolation. And then I'm going to go to this module, it has its own TS config. Cool, compile it in isolation. So now we can tell TypeScript to, instead of compiling like 100 files, we're compiling maybe 10 modules with 10 files, which it can do pretty quickly. So we are essentially having it figure out the same results, just faster because things are isolated.
It sounds like a form of caching almost, that we're delineating different layers that can be cached for reusability and downstream compiling.
Yeah, so it does include a little bit of caching in there. It produces this output, I believe it's called like tslib info, which is essentially just like a giant gobbledygook like string of your program. But if the inputs match whatever it has been cached, you're able to just like, oh, we already did this. We know what it is. Let's just reuse that information so that way we're not performing excessive builds.
I think what you're referring to, I just looked it up. I had to. TS build info files.
Yes, TS build info files. They're one of those things like they are a result of the build, and I never really look in there. So it's like I just have a mental like, all right, I'm just like ignore that file and keep on going.
One strategy is to separate one's project into, say, a monorepo style or just multi-package style using TypeScript project references. You also referenced workspaces. What is that?
Project references essentially pull in your types for your module and for your isolation, like for an isolated compilation silo, but it doesn't necessarily resolve how like external dependencies get in there. Project references, because it treats workspaces, because they treat everything as if it's like its own node module, is pretty easy to resolve. So if we're having stuff all live in the node modules directory, TypeScript compiler can understand where those symbols are coming from. And even though it's still just local to the same project, the resolution is all done through node, and then the TypeScript compiler can only focus on the types. So it's a little bit doing less work on the compiler side, but it's also following kind of better practices of making sure your code is easy to import all around the project.
So I could have a bunch of separate projects set up locally in my repo, and then using workspaces, I can have them fancy schmancy symlink pointing at each other. And then all TypeScript has to do, if I'm understanding this, is just cache or set up the TS build info between those different projects.
Yes, in a very kind of like vague way of describing it. There's a little extra work, and it's kind of why, in my talk, I kind of was like, hey, you should probably use a monorepo tool, whether it's NX or not. There's a couple of other tools out there that also do this, where I'm in project A, and I have a dependency on project B, project C. I need to include those references in project A, but they also need to be referenced in the base TS config. So there is like this very weird duplicate effort of declaring the project references on the TypeScript side across the project that you actually need them, but also the base project. And so like NX in this case, because we know all the dependencies inside of your monorepo, we're able to automate some of that and make sure that those are included in there. If you were to do this on your own, this is probably going to become a very painful project, especially if you have 100, even 50 different packages that you are trying to maintain, because every time you include a new dependency, it needs to be updated.
Okay. So this sounds like one pretty severe, strong point of performance pain for a lot of folks. There are a lot of other kind of zones we could dive into for TypeScript performance that unfortunately we don't have the time. But are there any other hidden gems or particular things you want to cover in this area before we move on?
Yeah, and this is a fun one of just editor completion or editor like responsiveness. You could be inside of VS Code, you could hit your trigger character, you hit that dot, and then all of a sudden you're sitting there waiting and waiting and waiting and waiting. And then you finally get an actual return from like, oh, here's all the symbols that are on this object. That's a terrible dev experience too. I don't know anyone who would want to work on a repo like that. And the example I kind of highlighted is actually a really fun one from a community member, where they created this very deeply nested TRCP router setup with very deeply nested types, and they generated it so that way it was creating 100 routes, all with very complex types, so that way the TypeScript kind of language service is having to go through and like really try to figure out what the type is for this one TRCP object. That's terrible. I call it tomfoolery, but there's like more colorful language that you could use to like describe it. Um, and so like one of the resolutions that we kind of worked with him on figuring out is like, what if we could just pre-build everything? So instead of having the language service like evaluate all of your types on the fly and to figure out like what are all the symbols and what are their valid types, if we just ran a build and generated a static DTS file, like we could just return that information versus having to do the live evaluation, which ends up working out a little bit better. It's still slightly slower than not doing this tomfoolery. But it does kind of get back to the point, like if you are running into like live evaluation issues where your completion is slow, trying to find workspace symbols, that becomes very slow. Pre-building things could be a very valuable improvement to your setup.
Just as an anecdote, I once did a performance consulting call for a company. They were using things like Zod and TRBC and whatnot, but their biggest performance issue was a multi-megabyte JSON file that they were compiling each time into a DTS that was itself multi-megabytes. And yeah, actually, your strategy was roughly what we did. We pre-compiled into a much smaller DTS, and it saved a lot of time. I think that's really cute.
A multi-megabyte file.
It's terrible.
Yeah, and I bet you, the developers, did not like working on that project, and probably were very thankful that you came along with that solution.
Yeah, but I like this. So okay, so you can pre-compile DTS files. Have you found that there's a lot of good tooling support for this? Is this something that's easy to set up?
Yeah, for the most part, it's like you treat all the individual packages at this point as if they are going to be published to npm. So you include the entries in your package JSON for all the exports, the types, the entry points. And I think a very simple way of doing it is having a post install script that just runs the build for all the dependencies and all the projects. And that's really as complex as it can be. I'm sure you could do more, but like a post install script that just calls npm run build for all the dependencies is valid enough.
There are worse things one could set up.
You could over-engineer it, but sometimes the simpler solution of just hook into post-install tends to be the better one.
There are a couple of spaces we could kind of explore now, I think. One is TypeScript Go, which is very exciting, and the other is kind of the organizational strategy. I'd like to segue into the latter. How would I know if I'm a web platform person or team or startup founding engineer, whatnot? What type of strategy should I pick, or what's the algorithm for choosing how to set up these fancy tomfooleries?
I would look first at just like have regular metrics and analytics over your builds. If you're like a founder and like a solo engineer, you're gonna know the pain points and how long something takes to build. If you're more advanced and you have like a team of people, check your CI times, check to see like how long are we waiting before PR gets merged, we ship to production. Like what's the delta between when things actually get merged in and when it actually gets released? If you're spending more time waiting on a PR to turn green, that's pretty bad. So you check that, you figure out, okay, we're spending this one PR probably took like 10 minutes. We have maybe 100 PRs over a week. That's a lot of wasted time just waiting for CI to just run a build and validate everything. Kind of one of the things that we do inside of NX is like show like how much time you've saved by setting things up in a correct manner and taking advantage of caching and taking advantage of these techniques for organizing your project. So that way you can see there is some validation. Like if you did not do this, you'd be adding an extra 100 minutes to your waiting time for CI. So look at the CI times, look to see how long you are waiting between each PR. And if you're feeling like it's too slow, you tend to know you're a pretty good judge in that regard. If it feels too slow, take a look at some strategies. If not, continue on your merry way.
You say time, I hear both time and money. right? CI time is both literal money spent in CI and the engineer's salaries.
I mean, from an engineering perspective, you never think of money, but from the business side of it, it is very much a costly expense. It's so much time waiting for Circle CI or some other CI provider to just like finish running, and then you're just waiting there. It's the XKCD comic of, oh, it's compiling. Oh, it's in CI.
So let's say I've done that. I'm on a non-trivial company size. I have a full team around me. I'm in charge of web platform. Woo is me. And I know that one of our big problems is lack of caching or lack of project references or workspaces. What do I do? Kind of how do I start my team organizational journey towards this nice caching Eden?
Start it kind of look at your dependency list. Honestly, like I think this is something that we still try to figure out on a per client basis or per customer basis. There is no like real easy way of mixing both paths in project references as far as I understand it. I think they're kind of exclusive, so you have to kind of either adopt one or stick with slow builds. If you realize that you need to move to project references, you could utilize some AI tool to go through and analyze all your workspace and say, hey, create a TS config for all these projects and migrate our main monorepo over to project references. And that seems like a pretty easy thing for any kind of AI and AI with some MPC input.
What about the kind of organizational side? How would you sell these sort of approaches to teams who are used to the simpler project structures?
I would sell them as pushing isolated modules and boundaries more than what paths would do. No one likes to find out that they imported the wrong module or the wrong symbol into their project and then oops, you accidentally imported something that was meant for Node, but we don't have a really good naming convention. And now it's throwing an error because well, paths don't exist in JavaScript in the browser. With project references, you can kind of really push the team on isolation and modules inside of your code base. And that forces those boundaries between here's something that is solely its own isolated context that is never going to be imported into a web project, because we set the compiler to know that this is targeting Node. We're only doing this. Kind of forces that boundary and that isolation even further than just good naming conventions.
Now that you mention it, having a TS config per project opens up really nice opportunities to set compiler options per project, right? So you can say like different lib types or whatnot in different parts.
Yeah, and if you have a multi-platform monorepo where, like I said, one team's working on like a Node backend, one team's working on a React front end, it's easy to separate what can be compiled for one context, and you get that feedback a lot faster if you do things wrong.
Is there anything else we should cover on the organizational side before we start talking about Go?
Let's start talking about Go.
Okay,
I'm excited about the Go part. I really would love to talk about it.
Oh, well, explain. What are you so excited about? Why are we talking about Go?
I don't know if you know this, but the TypeScript team is porting TypeScript to Go. And that is going to be something that will improve performance by like tenfold, if not more. I think it's going to be probably one of the coolest, like, once it does ship, it'll be like one of the coolest releases in a long time.
10x? That sounds hyperbolic. Do you actually mean 10x, Mike?
I do, if not more. There's a really good video from the TypeScript team, from Anders, one of the original creators, on the Go port and their initial kind of findings for it, where they were showing the performance benefits of a compilation speed which took a couple seconds to run, and then the TS Go version that ended up taking like milliseconds. And if it's a very small, trivial example, it's probably not that impressive. But imagine the improvements that can be made in a larger project now that you're using a language that also offers some kind of parallelizing of tasks, Go's multi-threaded. It can run things parallel to one another. So you feed it a big project, it splits off into multiple different streams or different threads to compile each one of those separately. That would be great.
One of the things I find fascinating is that the 10x, the literal 10x improvements that they've shown, give or take a percent here or there, are just from the initial pass, right? Like they ported as much as possible. They roughly kept the initial existing structures. And that was 10x. Imagine what it's going to be like after 6, 12, 24 months of optimization post-launch.
Yeah, and like there's nowhere it could go but up. I think it's kind of a good thing that they chose a language where porting stuff is easy to do, like the syntax and the semantics for like what you're trying to do in JavaScript and how you can do it in Go. There, you can get to the same results pretty easily. But now they're going through the whole entire code base and realizing, this is a little weird. Why are we doing it like this? Maybe we can also improve the actual TSC program itself. There will be performance benefits. It's just not just the language change and the improvements there. It's just the whole entire thing. It's going to be so much better if it gets here.
Let's talk about that. When you say if or when you say when, what are your thoughts here?
I tend to be a little bit more pessimistic about these things. I mean, TypeScript 5 came out in, I think, like 2-ish years ago, 2023. We are on 5.8 as of February. So their releases tend to be a little bit slower. It's a large project. It touches a lot of code all over Microsoft and other organizations. So intentionally being slow is good. I had initially thought that we'd probably see it by like 2027. Maybe midway through 2026 would be like the really hopeful outlook. But, you know, when they went from like the blog, TypeScript blog open, they have March 11th being like the initial like preview, and then May 22nd being we have a package, you can install it. It's not feature complete, but please try it. Maybe they'll get it in for something sooner. They said the target release was TypeScript 7 should be the full Go option, but maybe they'll have a use native flag in the compiler that people could enable.
It's a fun case of the TypeScript project using Semver to its advantage to have a 6.x version in parallel at some point to the 7.x. It's kind of funny.
For a project that isn't known for following semantic versioning at all, hopefully they will actually do that with the new release.
I look forward to that being possible at a language scale. But okay, so let's say that I have a very slow project and I've set up things, I've set up project references, I've even set up performance optimizations we haven't talked about, like isolated declarations and such, and it's just still slow. I'd like to try out TypeScript Go. Do you have any suggestions or pro tips for me?
Honestly, I don't, because TypeScript Go is not feature complete. There's like certain features in it that are not enabled yet. So there is like this -- build flag, which is necessary for project references to work. TypeScript Go doesn't have that yet. When it's supported and when it's ready, hopefully all you should need is either replacing TSC in your npm scripts with TSC-Go, or adding, like I would say, a compiler option that enables it for like either that one project or for your whole project. So there is no like easy solution for this at the moment, at least as far as I know. I have not followed the progress of the TypeScript Go development, so I'm sure you're a little bit more knowledgeable on it.
I am Not that. I don't have that much more information. I will say, though, that it's very telling about your response that you didn't start going into the structural differences and how you have to restructure and change your project configurations. It's, from what everyone has seen, roughly the same. So actually, you've been very good at using the right word here, port rather than rewrite. What's the delineation? Yes. Why is that important here?
So a rewrite would be, you have the same concept in program A that you want to do in a different language. And so you rewrite it, you basically rethink the whole structure, rethink the whole entire implementation. So that way it's a different, even though it's in a different language, it's a different approach to solving a problem. And that the port, instead of a rewrite, is very different because they are taking the steps of, we're writing it in a different language, but the instructions for how TypeScript compiles something is operating in the same steps. So it's like, read in the project config, read in the files, analyze the AST, produce the final output, and produce the DTS in a very kind of like hand-wavy steps. They're following the same steps instead of trying to, well, what if we did it in a different direction? What if we did it in a different order? Their promise to port it and to keep it as close to the original implementation, at least in terms of what it is doing, is really what I think is going to enable like the interoperability or the compatibility between the non-native implementation.
So this is then why they haven't, say, done it in Rust or C# or some other language that's a little more distant from JavaScript?
They probably would say that's probably why they picked Go. I don't even think like the language really matters. I think as long as they are approaching it in the same process of, we are just trying to re-implement these steps in the same exact order, the language doesn't really matter. But I'm sure the Go syntax is more familiar for folks who are doing mostly JavaScript and TypeScript on the day-to-day. So there's probably something about ease of adoption.
I'm also trying in my mind imagine the Rust model working for a direct port, and it sounds like it would be quite a bit different too. Yeah,
it'd be a lot of hard to read code, and I'm sure contributions would be very tricky for external contributors.
That is an interesting point here. I think part of the reason why they waited this long to do a Go port, not just because of how much effort it is, but because having TypeScript and TypeScript allows, just one language knowledge people to contribute. There's a bit of a downside here, no, of switching to a different language.
Probably. I think the different language, if you're doing, and I don't want to like sound like I'm poo-pooing anyone's contribution that isn't considered meaningful, but if you're doing high impact kind of contributions, the language that you're using really doesn't matter too much. You already have the systems knowledge of how this whole entire thing works. Whether it's Go or Rust or whatnot, it kind of, doesn't matter. If you're just making hey, this comment or this thing was not as clear as it could have been, you don't really even care about the language either. You're just going to make that one change or comment. And not to sound like I'm pushing AI tools, but I think you can get pretty far with some AI tools and AI powered like IntelliSense that having to know the entire depth of knowledge of Go it's not a need that you need anymore.
In this world where you have things like AI tools to help you develop, where language specifics are a little more obfuscated from you, what do you think the main TypeScript pieces of knowledge or foundational concepts that are going to be most useful for folks then?
Probably just how types work and the flow of types. Are we talking in user program or in the TypeScript contributions?
Let's talk user programs, although I would really love to dive into TypeScript contributing at some other point.
Yeah, in user programs, like, it's as long as you are fully aware, like, you could probably build something with full AI tools and just get something that works. But if you don't understand what's being produced and how data is being flown around and how the types are working, you're probably not going to have a good time. And maintenance is going to become a pain when you eventually have to update it.
So, regardless of whether your TypeScript is 10x faster or 100x, what are some of the kind of lines that you would draw between good uses of the type system and too clever or confusing uses then?
I'm going to blank on the name of them. Template literal types. There was just like, once those kind of came out, I think there was like we're going to make a type for every valid area code or phone number that could ever exist. And there were people who were just creating these giant types of like nonsense. I was like, okay, that seems excessive.
They have Doom now in types.
They have Doom in types. Great that you can do that. Probably don't ever do that.
Yeah. But, this is kind of a natural trend for developers, right? Where you have something, you have the powerful type system or feature, you're going to want to use it. And it can be hard to know whether you're using it correctly, that you're actually using the power where it's worthwhile, versus you're just kind of going down a rabbit hole that isn't actually beneficial. Do you have any tips for coaching teams away from these type system gymnastic shenanigans when they aren't actually useful?
If you find yourself actually having to go through and type like as unknown, as any, or like kind of coercing like the type to be what you need it to be, you're probably going, if you have a lot of those, that's probably a code smell. And you should probably figure out, okay, we have an Electron project, and Electron has its own API that they bolt onto a window. How do we make sure that we do that in a way that is actually providing the correct types, but we're not having to go through and parens window as any dot electron or window dot any as any dot insert any third-party library. There should be ways where you are actually providing the correct information for whatever library you're trying to use to the program, and do it in a way that doesn't feel like, oh, I have to make sure that I remember as any or as my type. There are ways to extend the official built-ins. You just gotta read how to do it. Great. Or have an AI do it for you.
Something doing it. All right. Mike, I have no more long-form questions for you. Before we go into the quick rounds, do you have any other points you want to bring up, things to discuss?
Yeah, I think the big thing, performance issues, like I said at the beginning, most people don't ever run into the issues that I kind of highlighted and talked about. When they do, they can seem daunting, but take it one step at a time and you'll be fine.
That's a good life advice.
One step at a time.
Things one step at a time. Awesome. Well, speaking of small steps to take one at a time, quick round. How do you prioritize fast builds compared to or along with perfect type safety?
Take this approach of get it green, then make it better. So whatever to get something to build and then iterate.
Great. TypeScript Go, will it ship in 2026?
Not likely.
Mm-hmm. Build time over 2 minutes, acceptable or deal breaker?
2 minutes locally or 2 minutes on CI? One of those is a better 2 minutes. I would say if it's...
Two-part question then. Locally and then in CI?
Locally, unacceptable. On CI, acceptable.
Okay. If TypeScript disappeared tomorrow, what would you miss most?
Everything. Like I said, I remember the days before TypeScript. Those are very, very dark days. I'll miss the IntelliSense probably the most.
Mm-hmm. The typing a few characters and seeing the list or the dot and then the list of options. Yeah.
The tools that existed that did that before TypeScript. I had to look it up because I forgot about it. It was this one called Turn.js. Turn.js. TERN. It was great for its time, but boy, was it not TypeScript. And it was amazing that they were able to do something like that.
This looks like an older web. If I'm looking at the website now, I would highly encourage any listener who has spare time to go and deep dive. This is a fascinating project. Okay,
I think it was originally made by the person who did Code Mirror.
Oh,
yeah, Code Mirror was the one of the original authors of it, who did Code Mirror and Prose Mirror, wrote Turn.js.
What an MVP. All right, last question, Mike. This was not on the pre-approved list of questions. What's your perfect Saturday?
It's raining. I have a nice coffee. I have no plans. And I just get to hang out kind of at home, work on my hobbies, and not feel like I have to be rushed to go somewhere. I'm a pretty easygoing person. I'm a homebody at heart, and I love it.
That sounds lovely. All right. Well, thank you so much, Mike. This was a fantastically fun interview. We talked about TypeScript performance, about project references, workspaces, the dreaded path aliases, TypeScript Go, and of course, your perfect Saturday. I think that's all we have for today. So thanks for listening, everyone. This has been Josh Goldberg and Mike Hartington. Cheers.
See ya.